on page 524. It's okay, we'll just hear giggling in the background. 2A. So 2A, we have our Cl2. It's gas. I'm just writing the whole thing up on the board. You guys have this information on yours. No. If you're like me and you like to have a visual and be able to write beside it, you might appreciate it. Some of us are going to have to work through it as we go. So, what we're going to do is we're going to look at this and we're trying to find out which way our chemical reaction is going to shift. Okay? So, if I look at it, I have a endothermic or exothermic? Exothermic. And we know it's exothermic because it's found on the right-hand side, which is being released, right? So no, it's released. So that idea causes us, if we look at our questions there, it's asking us what would happen. So if I have a exothermic and I increase the temperature, it's going to shift to the right here. So this causes, this exothermic causes a shift to the right. Now we're going to look to see what else there is. Okay, we have pressure to consider. So pressure or volume change and that type of thing is when we have only gas. Do we have gas present? Okay, we have gas present here, right? So that gas present, if we look at it, I have 1 mole, because that's where I get that number from. And on this side, I have 0, right? This one's aqueous. I don't have any gases over here, therefore there's nothing over here. Or 0.
So we just ignore it.
Right. Yeah. Just look for gases only. So if I have 1 on this side and none on this side, again, I'm going to shift to the right. Again, if I look at my little chart, we looked up more reactants, telling me it's going to shift to the right. Are we okay with me so far on that? Kind of? Which part are we uncertain about?
How do we know we're shifting to the right?
So if I look at the chart that you have, or your table there, okay, if you look at your ones that deal with the reactants, for pressure and volume, so if you increase the pressure or decrease the volume on the reactant side, it's going to shift to the right. And if you decrease the pressure and increase the volume, either way, it's still going to shift to the right. So no matter what I do, if I increase the volume or increase the pressure, it's going to cause the system to go this way. Basically, that's because there's gas on this side, but there isn't on this side. It's push this way. Whereas when we're looking at our exothermic, okay, so if you look at your exothermic aspect there, so if I have an exothermic one, and I decrease my temperature, then it's going to move to the right. Okay? Because your reaction wants to be more random. Like it wants to have more space between the molecules, it wants to be able to move more. So it's going to shift to the side that it has more space. So your little particles are going to move all over the place. Is that better? A little bit? Okay. As we work through it, I'm sure it'll come. So because both of them are saying a shift to the right, our answer for this question then, because it's asking, like, is it going to go to completion? Is it going to reach a state of equilibrium or not at all? It's shifting to the right, so we are going to see it go to completion on this side, right? Does that make sense? So we're pushing all the way over here? Yes? No? we're going to completion, right? What's happening? We'll do the next one. Hopefully as we continue on, to make more sense to you. I'm just going to make a new page. Okay, so this one's 2b. Could I get someone to help me out with the equation was? Like a solid? Okay.
Plus H2O and
It's a liquid.
arrow and A plus and Q plus OH goes to negative and plus 1/2 H2 and goes to I think what's semicolon? The triangle equals negative 184
kilojoules. Okay. So, first things first, temperature is the easiest one to look at. Is this an endothermic or exothermic? Exothermic. The reason why it's exo because of that negative. So we know this is exothermic. Okay. So it's gonna wanna shift to the right as we discussed before. And again, you can use your chart there. So I know that there's an increase in temperature for exothermic and there's a decrease in temperature on exothermic. Remember, it's more likely that something is going to be given off heat, right? Right? So therefore it's going to decrease in temperature. So it's going to shift to the right. I guess a more common route. Okay, so that's why it shift to the right. So the next thing that we know or what we can look at is we need to look at our moles to see if there's anything different there. Because we're not being told anything about concentration of reactions, right? So I don't know if there's any increase of reactants or products, so I can't do that first section of the chart. So if I look at this one, do I have any gas? Yeah?
But you have
A half H2 on the right there. Okay, there's a slight amount there. So I'm gonna, sorry, my arrows over here says there's nothing here, but over here there's half, right? On the left hand side there's 0, but on the right there's a half. Okay, so products have more moles. So what happens if I increase or decrease my pressure? It's going to shift to the left. So this here tells me it's going to shift to the left. So if I have one thing that's telling me it's shifting to the right, and the other thing is telling me it shifts to the left, what do you think is going to happen? Well, the idea is that they're all in equilibrium, that they're going to be working back and forth, right? So no change is going to happen here. Okay? So equilibrium with no change, right? Same idea, does that make sense? Yeah. I'm just saying another way of thinking of it is that there's no change. Sorry. I worded that poorly. Okay, so equilibrium. Okay, so one was left, one was right. Basically a 0. Moving on, okay? Why does it have a fraction in it? Technically you could have like 1 mole instead or whatever. They decided to be fractions. Why exactly? I'm not entirely sure, but that's why they decided to do this equation. Okay with 2b? Sure. Are we doing a little better? Okay. Remember, if at some point you're feeling pretty confident, you want to move on, look past what we're doing, that's okay. You can always go and look at these afterwards to see if you're on the right track. For those of us that want to continue, that's fine. So can someone help me out with what C has?
No, it's gas. Sorry. Gas. And then arrow. NO2. And then triangle H equals positive 33.8 kilojoules. Yeah.
Okay. Alright, so our change in enthalpy or the change in heat is at 33.8. That positive tells me what? It's endo. Okay. So if I have an endothermic one, it's going to shift to the left. It was on the right-hand side of the equation.
Oh, yeah.
Okay.
Wait, how do we know that it's shifting to the left?
Okay, so if we look into our little chart there, and we look at endothermic, okay, it's going to try and favor the side that's going to make sense to it right now. If we increase the temperature, it's going to favor the forward direction, right? If we decrease it, it's going to shift to the left. If you think about it, more likely, because it doesn't say that we're going to continuously heat it or whatever, it's probably going to be decreased, right? Stop at a certain amount, now it's going to decrease. So therefore, it's going to shift to the left. Is one way to think of it, if that works. Does that make sense to you? Most of the time, it'll indicate more than what it's given you here to tell you if it's an increase or a decrease. If you, and when we look over entropy and randomness, that'll make more sense to you too as it goes.
Like, where do we look in our chart to
The temperature one that says
like
endothermic?
which endothermic one?
Right, so what I said was that if there's a increase in temperature, you have been told that there's more temperature being added into the thing, and therefore you look at that one. Most likely in this case, you're going to lose heat, right, because you've added it in, but that's it. So we're going to lose heat, which is decreasing temperature. And write down which one I went to then.
Yeah, I'll figure it out.
So, next thing I'm going to do is what? Count the moles. Moles of gas, right? How many do I have on the left? 1.5. So 1.5, 1.5, everyone can call it. On the right. Which side's bigger? Reactant side is bigger. So, whether I increase or decrease the pressure, what's going to happen? It's going to shift to the right. Okay, so if I have one shifting to the left and one shifting to the right, what's going to happen? Equilibrium, aka no change, right?